This video teaches you how to use visual slope to perform a slope stability analysis with composite failure surfaces. As we know, for soil slopes circular failure surfaces can be used, while for rock slopes translational failure surfaces should be considered. However, for a case like this, the slope consists of a soil layer on the top followed by bedrock. We can perform a slope stability analysis with circular failure surfaces. We find the most critical factor of safety for this analysis is 1.34. However, the common experience tells us that for the slope like this, soil most likely will slide over the interface of soil and rock. The failure surface would be a circular section followed the interface and a circular again. For this type of failure surface, so-called composite failure surfaces should be considered. A composite failure surface consists of a circular section followed the interface and a circular section again. To compose composite failure surfaces, we first draw limit lines along the interface. If we run a slope stability analysis, we will find the failure surface is still circular shape. If we show all failure surface, we will find none of them go below the limit lines. However, this is not the analysis that we want. We want to have composite failure surfaces. Therefore, we should choose the composite failure option. Now let's run slope stability again, and we find, this time, the failure surfaces start from circular shape and then follow the interface and change to circular again. The factor of safety now is 1.26, which is lower than the previous one of 1.34. Many commercial slope stability analysis software can perform composite failure surface analyses. However, visual slope goes step further. The strength of the interface, commonly, is lower than that of the original soil due to existence of water along the interface or other reasons. Visual slope can simulate this condition. First, click the limit line and in Line Edit page, specify a reduction factor. We can specify the reduction factors of other limit lines with the same approach. After the strength of the interface is reduced, we can perform a slope stability analysis again and will find the factor of safety is even lower. This example is to simulate an interface between a soil layer and the bedrock. We will present two other applications. The first one is for landfill cap. After a landfill is completely filled up, a geomembrane and then a clay cap will be placed over the solid waste to seal the landfill. The clay cap may slide down over the geomembrane if it is not designed properly. To simulate this condition, composite failure surfaces can also be used. First, draw limit lines to simulate the geomembrane. If any reduction is needed, the previous procedure can be used. Then, we perform a composite failure analysis. The result indicates the factor of safety is less than 1, the design may need to be modified. Another example is also for a landfill project. But this time is to analyze solid waste sliding over a geomembrane that is on the top of the clay liner. The procedure is similar to the last example. The above three examples demonstrate how to use composite failure surfaces to simulate an interface. Thanks for watching.